This is video on statics of coplanar non-concurrent forces. This is the sixth video. Here we are looking at examination problems which appeared in Mumbai University on this topic of beams. So let's have a look. December 9, this problem appeared wherein you are required to find the support reactions at A and B. Now there are two triangular loads and one uniformly distributed load and one moment. So what do you do? What you do is you simplify these loads. How you do it is you put equivalent load. See, this is 20 and this is 3. So 20 into 3, the area of this triangle is 20 into 3 by 2. So that is 30, and that equivalent load is supposed to be acting at the center of this triangle. So 2 meter from A. So this is what exactly we replace it with. We do similar operation for this load, this triangle. 60 it will be at 5, and this 10 into 20 acting at 1. Once you have this in place, you are reasonably simple loading. Now you replace the supports by appropriate reactions. So hinge, so HAVA, and roller, so VB. Now to this entire system, let's apply sigma fx0, sigma fy0, and sigma m0. Sigma fx0 simply tells me that HA is 0. Sigma m equal to 0, that is, I'm going to take moment about A of all the forces. What it tells me is VB into 9 minus 20 into 10. The reason for minus is the sense of the moment is negative. And then I have 60 into 5, and then I have 30 into 2, and this concentrated moment I keep as it is, and plus 20 because it's anti-clockwise sense. So this equation enables me to work out VB. And then I write sigma Fy equal to 0. What we get is VA minus 30 minus 60, minus 30 minus 60 minus 20, and plus VB, which is worked out to 60, is equal to 0, tells me VA. So you have HA, VB, and VA worked out for this beam. Look at May 10. Supports are already replaced by reactions. Write sigma fx equal to 0. It tells me 8 cos 45 minus HA is 0, gives me HA. Taking moment about A, what I get is VB into 9 minus 10 into 3, 8 sin 45 into 6, and then I have these two concentrated moments. See, so 6 I put it as negative because it's clockwise, 5 I put it as positive because it is anti-clockwise. I'll be able to work out VB from this. Now we do sigma Fy to this. So sigma Fy equal to 0 tells me VA minus 10 minus 8 sin 45, which will be 5.657, plus this VB 7.216. It gives me VA. So we have worked out HA, VB, VA, all the reactions for this beam. Let's look at May 11. You have this triangular load. Best thing is to replace it by a simple load that will be 6 into 2 by 2, acting at 2 from the left end. That is 6 at 2, and similarly this will be 4 into 2, 8, acting at 2 from the right end. Loading is reasonably simple. Now the support reaction. Here is a roller, here is a beam. So we replace them by the appropriate reactions. VA and hinge, so HB, VB. Now we write sigma fx equal to 0, that gives me HB. Sigma m equal to 0, take moment about A. What I get is VB into 15, 9 plus 6, 15, minus 6 into 2, minus because now the sense of the moment of this 6 is clockwise. Then 8 into 13, this 8 into this distance 13, then minus 3 sin 45 into 11. and plus this anticlockwise moment n equal to 0. So I get VB and then uh, let's do sigma Fy equal to 0. So what I get is VA plus this VB which we have worked out 8.622 minus this 6 minus this 8 and minus the vertical component of this 3 sin 45 equal to 0. So that gives me VA. So you have HA, VB, VA. 3 reactions worked out for this beam. Look at the last one, December 8. Here the problem is slightly different. Load is unknown and we need to find. But what they have told us, so 1 minute. So this, as usual, we have simplified this triangular load into a vertical load. And what they have told us, that this HAVA at this hinge support, the reaction at support A is 0. Means HA and VA both are 0. This is the information given. Usually you find this reaction. Now they are telling us this is 0 and we need to find P. No issue. Just apply sigma Fx0, sigma Fy0, sigma M0 to this. You have been told HA and VA are 0. Fine. So you just take moment about B this time. Because see HA, VA are known. So we take moment about B. We get 36 into 1 anti-clockwise, so positive. 10 into 4 anti-clockwise, so positive. This 50 negative because it's clockwise, and P into 1 clockwise, so negative. See, only unknown is P. One can work it out. And then you write sigma Fy equal to 0. So you get VB. VA is already 0. Minus 10, minus 36, minus 26. Where P is 26, and you get your VB, and you have worked out the unknown reaction as unknown load as well as this unknown reaction VB. So this is how you applied equilibrium equations to the beams and solve for the reactions. Thank you.